All right, so let's talk about NMR of chiral compounds now. And this has actually kind of been an interesting experiment for me to go through and try to understand this. Because if you look at NMR chiral compounds, there's software that will predict it and it gives what I assume are accurate predictions. I don't know. But in terms of people explaining it, I really haven't seen that much online. It's been kind of fascinating to me go through and try to figure this out, because there are lots of chiral compounds, particularly when you start getting to rings. You'd expect there to be chiral compounds because it's just so easy to generate chirality on a ring. But why do textbooks and why do resources seem to be so scant on information of NMR chiral compounds? And the short answer, I think, is that it's kind of a niche field and it's super hard to work with. So we have better techniques for determining chirality than using NMR. Why take this expensive technique, develop an analysis around it when we already have techniques that can solve it? So a few things I picked up on. Okay, so before we get any further, just to qualify here, we're not going to be doing NMR chiral compounds. We're going to stay away from them. The big reason being is that it's something better reserved for a graduate or a higher level organic chemistry course, but not organic 1, not organic 2. So what did I find when I was looking at it? Well, one of the big things I found at first was that if you have a single chiral center, particularly with a molecule that that's a branched alkane, so not cyclic, but a one chiral center NMR, one chiral center molecule that's a branched linear alkane, it does not actually show any differences under NMR. So no, using just straight NMR as a traditional technique, you cannot use NMR to resolve RS centers if it has a single chiral center and it's a branched or linear alkane. But if you have a chiral solvent or a chiral solvent that you use to dissolve your molecule, actually in that case you can. Actually, because the chiral solvent has an effect on the magnetic field, it will affect one conformation over the other. So this is actually a thriving field of research right now where people are trying to figure this out. If you have more than one chiral center, in principle you can do it without the chiral solvent. And again, this is kind of as of the date I posted this, and this is what I'm able to find online, looking through people's published articles and theses and things like that. In principle you can, because when you have two chiral centers you actually create asymmetric magnetic environments within the molecule itself, and so in principle you can resolve different enantiomers and diastereomers. That said, we're talking about R and S. When it comes to cis-trans, the best I can tell is that no one really has been able to prove the difference between cis and trans. Now, you may sit back and say, well, in a previous video you talked about dihedral angle, it's got a cosine on there. And so when you flip pi, you're basically, for the cosine, you're going between 1 and -1. So yes, in principle you should be able to see it, but I'm not really seeing anyone publishing any information out there about it. So when it comes to chiral compounds, big picture here is that we're not going to make you predict NMR spectra for chiral compounds or be able to backtrack them. You're going to see a lot of asymmetry, and that's mostly what I've noticed, is that in compounds that do have chiral centers, particularly if you've got more than one, you will start seeing asymmetry in terms of the splitting patterns. This is because you have different bonding environments, but again, this is kind of an emergent field. A lot of people have been putting a lot of effort into this because we have other techniques for resolving it.